We're now ready to do the hydrology for our drainage network. The first step in the hydrology is to enter the catchment areas. So once again, we'll return to our network editor and we'll go pick one of our inlets on our project. I'm going to cross here to inlet number I05. Now on this inlet, if you go to the catchment tab, you'll notice that we have three sets of catchments. Now the idea here is not that you may have three catchments draining to that one inlet, although you could. The idea is to use them for catchment management. So set number 3 could be your parklands, set number 2 could be your lots, set number 1 can be your roadways. But it's up to you to decide how you're going to use the three sets. The simplest way to enter a catchment area is simply to type it into the catchment field. Now there are some times when these catchment fields are not going to be accessible. For example, if I was to move over to manhole number 1, MH1, you'll notice that I cannot access any of my catchments. Inside our drainage.4d file, we've specified this is a manhole, and manholes do not accept any inlet water at all. Also, if I was to go down to the end of our network and go down to our head wall number 1, I also could not enter any catchment data. The outlet from a 12D drainage network never has any catchments at all. The second method we're going to show you for calculating catchment areas is having that determined from a catchment polygon. Now I'm going to maximize our plan view, and I'm going to add in a model that we read in earlier from our AutoCAD file, that DWG drainage catchments. Now what's been drawn here are 5 different catchments, and there's one rule that's been followed when these were drawn inside the AutoCAD program. That rule is that you have to start near the inlet that the water is draining to. So this catchment could have been drawn in this direction or this direction, it wouldn't matter, clockwise or counterclockwise, as long as the first point you draw is nearer to this inlet than any other inlet. Now, to set up our linking, all the linking inside our network editor is done on the global utility models tab. You'll notice that there's catchment links, road design links, overland flow links, and service links. So right now we're going to concentrate on our catchment links. This is done via file. So the file we're going to create is going to be called My Catchments. You have to type that in. And then, as we have with many of our files, we have a custom editor that's accessible by selecting the folder and then going down to Open. Now inside here we have 3 different cells, one for each one of our catchment models, catchment sets. And of course each set has its own model. Now we only have one model of catchments right now, so we're going to place them in set number 1. So I'm going to select set number 1, do a right mouse click, and select our model DWG drainage catchments. We're going to be talking about these TC fields later. Now let's write that out and then select Finish. As all the operations inside 12D require, you have to push a button to make the calculations happen. In this case, it's the Set Catchments. Now just before we do that, we're going to put in 2 other optional fields. The first one is Labels Model. So I'm going to create a new model called Drainage Catchment Labels. And the idea of this is that we're going to have labels show up at the centroid of the catchment, indicating the catchment area in hectares and the inlet structure that it's related to. In order to do this, we'll have to select a text style for that text. Now we're going to do one other thing. We're going to turn on this tick box here, the auto rename, and that's going to give us one other method to confirm our linkages. It's going to change the name of the polygon to the inlet that it's linked to. And you'll see the advantage of this shortly. So now that all of this is set up, we'll hit the Set Catchment button, and we'd like to see those areas being shown on our plan view. So I'm going to go up to the plus button and add on that drainage catchment labels. Zooming in a little bit closer, you'll see that it's labeled with the catchment area and the inlet that it's been linked to. However, you'll notice that inlet 05 did not get the catchment associated to it. If I push my F2 button for my string inquire and go back and pick that string, you'll notice that the name is called not used. If I was to select this other one, it's called inlet 06, indicating that it's linked to inlet 06. I'm going to select finish on that. Now the reason this one did not get linked, if you recall, we manually entered a catchment area for inlet 05. And if you've entered a number manually, then it assumes that you've done that for a good reason, and it will not override your work with that string. If we did want that to be used, we could then go back to inlet 05, go to our catchment tab, number 1, and erase that area. Now if I was to come back and do a set catchments, you would see that a catchment has been assigned, the area has been calculated, and the new area is in this box. Now while we're on this, if I was to go back and change that area back to point 1 and then hit set catchments again, this time it would override it because we've linked a string to it. The string will override the setting that's inside. Now while we're checking this, we've given you already 2 methods to confirm it's been linked to the correct inlet, the name inside here and the name on the string. You might now see a third method. If I'm on set number 1 and a catchment link has been successful, you will see the highlighted catchment shape associated with that inlet. If I went to the minus and turned off our drainage catchments, you would still see that link. Now that link is for set number 1. If I was to move to set number 2, where we currently have no links, the highlight would disappear. Also, of course, gone for set number 3. However, back to set number 1, and I can see that highlight. And of course, as I move through the network, if I go next, I'd be seeing the highlight for the other areas. Now that we know how to link our drainage network to some polygons, we're going to look at drawing those polygons inside 12D. Now I'm going to get myself out of the drainage network editor so that I release all the locks on my catchments and my network itself. I'm going to add on my DWG drainage networks. Now you might have noticed what I've did there to get such a short list of models. Let me close that for a moment and do that slowly. I've put my cursor over top of the plus button and then gone and selected the D on the keyboard. This displays only the models that begin with the lowercase d, a much shorter list. Now what I'm adding on is my DWG catchments. Now what I'd like to do is to delete one of these catchments, especially this one here, and then redraw it. And you'll see why in a moment. I'm going to come up here and add on my tin combined. And one of the things you'll soon discover about a super tin is that it is opaque. You cannot see through it. So I want to have that drawn first, so I'm going to change the drawing order on our project. Sorry, on our current view. Selecting our view button, going down to models. There's 2 ways I could do this. I could just go models to back and have my tin combined sent directly to the background. Or new to version 8, I could have gone down here, gone to models, and changed the model order. And you'll see what's happened by sending the tin combined to the bottom of the list. It is the one that's drawn first. So this is the order that those are drawn, starting at the bottom of the list at number 5, working the way up to number 1, which is the top layer. Now this might seem somewhat backwards, but it is exactly the same way that our super tins are used as well. The top layers are number 1, the bottom layer is number 5. Select finish for that. Now this string here, if you'll notice, is all the water is flowing down in here, but also it's a sag pit. The water comes from this area as well. So we have the water coming from both sides down into this one inlet. And somewhere around here, if we toggled on our tin flow, we would see that the water would start to run across here and then of course down our roadway. Now to help us with all of this, we're going to come up here and add on our tin design. Now the reason I did that, of course, was to see the flow arrows. Now the flow arrows here are set to yellow, which of course is going to conflict with the color of our tin solid. So I might just come up here and toggle off our tin solid as well to make it a little bit easier to see those arrows. Now the idea of stopping our catchments for our lots up at this area here is that there's going to be an interlotment drainage at the back of these lots. So once again, I'll plan on stopping the area there. So my first step is I'm going to delete this catchment. So in order to delete that, I'm going to come across to our CAD toolbar to CAD delete. Drag this out all the way to the right where I have string delete. And I'm going to pick that catchment string and delete it. Now what I'm ready to do is to create the new polygon. Now, yeah, I could go and type the fields into my CAD toolbar up the top here, or I can use the same as button, the eyedropper at the end. Using the eyedropper, I can come down, select a catchment that's already been drawn, middle mouse to accept, and it fills in all of the values for that catchment. A much quicker way to go. I'm not concerned about the name because that name will be changed when I use set catchments again. To draw the catchments, I could use my CAD lines and then close it when I was finished. That is optional but encouraged. A better way to do it is to come down to CAD polygons. Drag that to the right. Come way out to the right where we have a freehand polygon. Now if you recall the area from AutoCAD, we talked about starting near the manhole, or inlet, pardon me, that we're draining to. Now you don't have to start at it. As a matter of fact, for a sag pit, we are supposed to follow along the crest of the catchment. So we should be out here somewhere. The idea is that this point should be closer to this inlet than any other one. So I'm going to start my polygon right about here, and then it will automatically get linked to this one. Now the idea here, of course, is that one catchment area is next to the other, so I'll follow that catchment around and come back up here. And following across, as I was describing, that interlotment drainage line as I come back to the edge of our tin. Now I'm going to zoom in a little closer here to follow the contours. The idea here now is that the water is going to be flowing down in this direction. And if this is where my interlotment drainage was tying in, my plan is to put another inlet at this location. So I'm going to move back up perpendicular to my contours in order to go to the road center line. Now if I wanted to be more precise, I could go turn on my road center line model to keep an eye on that to snap directly to that center line. Now the water is going to come down here, and I have to do a little bit of careful work to decide where the water will stop coming into the curb and gutter and into here and start flowing across. Well, looking at this, it would probably happen at a point near here, and if I went up 90 degrees to my contours, it would be happening just about there where I start losing it. So I'll come into there, following down 90 degrees. I'm going to follow down here till I get to almost my curb and gutter, and it's going to be my curb and gutter area that's going to be flowing in now. And then if I zoom out just a bit, the water that's going to flow in, this one is going to flow in to here. I'm going to have to follow that curb and gutter just a little bit more, and down into here. And when I'm all finished, I'm going to hit the escape key. Now you're welcome to turn on your road strings and follow those snaps closely, or draw them more freehand the way that I have. It's up to you how much precision you put into your catchments. Now we've gone and demonstrated how the automatic linking function works very well as long as the person drawing the catchment followed that one rule: start near the manhole that it drains to. However, often this won't happen. You will get catchments that are drawn by some other method, and you'll have to do manual linking. To do a manual link, I'm going to demonstrate it by taking this catchment area here and having it linked to this inlet farther down the road. Now I realize that what we should be doing is increasing the size of this catchment, but I want to show you how a manual link would work. First of all, I'm going to go to inlet 03. So I'm going to go to my drop down and select inlet 03. Move that just back. So now you can see it's highlighted there. Going to catchment set number 1, and I'm going to use this pick button beside the catchment polygon. And I'm going to go select this polygon. Now you'll notice how its name was not used because it never was linked to the manhole. I'm going to hit middle mouse button to accept, and you'll now see that that link has taken place. No catchment areas are shown yet. We must hit the Set Catchments button for that to happen. And now you'll see that it has a catchment area. It's been linked to a string, and if we zoom in just a little bit closer, it tells us that this catchment area has been linked down to inlet 03. A final and optional step is to color our catchment polygons with a translucent fill. This translucent fill will make it easy to identify any catchment areas that have overlapped each other or areas that have not been counted in our catchments. In order to do this, we're going to our Utilities, down to Superstrings, and selecting Fills. Now the model we're going to be working with is our DWG catchments, so move that down, DWG catchments, and we'd like to set the color for these. So I'm going to set the color to green. A value of 1 means it's supposed to be opaque. So I'm going to make it 50% translucent and come down here, and I'm going to use the Replace Data option and then select Change. You'll notice that it comes up and says aborted. The reason for this is that our network is locked as well as all the strings that go with it. That's been done by the Drainage Network Editor. If I select the Finish button, I can now come back and try again, change, and you can see that my catchment areas have been colored with a translucent fill. And you can see the small spots that I have not counted, and if we had any areas that were overlapping, they'd show up as a much darker green. You'll notice by default, however, we've lost the edges. If we'd like to change this view property, we'd move back up to our View button, come down to Settings, and it's the settings for faces. Faces is 12D's terminology for any sort of coloring that happens inside the strings. The default is to draw the fills. We'd also like to see the edges that go with that. So if we hit the Set button and then Finish, we now can see the edges of the polygons as well as the translucent fills. Now that we've completed our catchment drawing, the catchments, the labels, you might not like the catchment fonts that have been used. So we're going to take a look at creating or modifying a textile favorite. Now there's two places that we can do this. First of all, if we were back inside our network editor, we could be back and select our inlets and go back to that global utility models, right back to where we specified the textile. Selecting that button, we could come down here and select Edit. Now that will bring up that textile favorite and allow us to change just once this textile favorite for this one application. However, if we wanted to permanently change this, we could drop down our favorites to the very bottom and select Edit for the textile favorite. And this takes us all the way to the textile favorites editor. Now a much quicker way to get to that would have been to go up to Projects, down to our project tree. Inside the project tree you can expand all the different sections of your project. And if we move down here, it's textile data favorites that we're looking at. And if we wanted to edit them, we could simply come down here, area number 2, do a double click on that, and it would pop up that same textile editor. It's up to you how you get to it. Now if I wanted to create a new one that was similar, I'd probably come up here, do a left mouse click on the entire row, a right mouse click, and do a copy. Now I'm going to come back down to the bottom row, select the entire row by clicking on the 8, do a right mouse click, and go paste. And now I'm simply going to change this. And what I'm going to do is create a new name. I'm going to call this a little bit bigger. I'm going to make these 4 meters high. So I'm going to come down here, and I'm also going to make them 4 meters high. But I want to change the color for them as well. So right mouse click, and I'm going to make these labels an orange color, and then I'm going to set that. That will create the new textile favorite for this project. If I wanted these textiles to be available to other projects, I'd have to write them out to the textile names.4d file. If I save it to the current working folder, it'll affect all projects in this working folder. If I want to use it for all of my projects, I'd select user folder, and then all new projects that new and existing projects that I worked on would have access to these new textile favorites. Now I'm not going to bother doing that for now. I'm happy to have that in this one, so I'm going to close all these off. Now if I come back to my drop down, you'll see that I now have an aerial 4. And if I hit my set catchments, you'll see that I have a somewhat larger label now, and of course it's come in looking just a little bit off colored because it has the blue shading in front of it, the green shading. Once again, you're always welcome to change the order of your model drawing. So I could come up here once again to my views, go down to models, and I could models to front, and I could go and bring my catchment labels. Bringing those to the front now, the green would not be drawn on top, and I see the true orange color. Now that we have our catchment areas defined, we're ready to look at the percent impervious versus pervious. Let's move across to our catchment tab. You'll notice that on the catchment tab, there's a field to specify the percent impervious, and it's currently blank. A blank field means that it's using the default value. So let's move across to the Defaults tab. You'll notice the direct one-to-one correspondence between the catchments, the pits, and the pipes. So on this Defaults Catchment tab, we have all the default values for our catchment and our hydrology. Now the percent impervious is the only one that has a separate default for set number 1, set number 2, and set number 3. All the other defaults apply to all 3 sets. So returning back, it was blank here for percent impervious. Move to the Defaults tab and see that it's using the 90% value. The other thing you'll notice is that if we do use the overrider, and I was to change this to 100% impervious and hit the Enter key, that it would now be impossible to enter any data into the pervious column. That's because we have no pervious area. And once again, if I was to change this to another value, such as 70%, and hit Enter, we would have access to both the impervious and the pervious data columns. Now this concept of having a blank field, and whenever the field is blank, it's using the default value, is fundamental to using the Drainage Network Editor. It does not only apply to the settings you'll find on the catchment tabs, but just as much to what you find on the pit and the pipe tabs as well. 12D has the capability for entering different hydraulic properties for your pervious versus your impervious areas. First, we'll look at the coefficient of runoff. Besides having a pervious and impervious value, you can also have a different C value for a minor event compared to a major event. The concept there is that during the major events, the C values often are a little bit higher because the catchments are fully saturated, and your time of concentrations are somewhat faster because of the saturated channelized flow. So looking once again at the C value, once the fields are blank, and that means the default values are being used. Therefore, if I was to move across to the Defaults tab for the catchments, I'd expect to see default values in here. And both of these default values happen to be the same right now, sitting at 0.75. Returning back to that catchment tab, if we go looking for our C values, we cannot find any for the impervious areas. Now let's go across to the Global tab. This is the first time we've come to the Global Main tab, and on here we have settings that you can only set once for the entire network. And if we look down here under Catchments, you'll notice that we have an impervious C value here that you can input for the minor and the major storms. The concept of placing an unchangeable impervious C value is that concrete is considered concrete, or impervious is impervious, and there's not different degrees of it, and therefore only one C value will apply. The moment that you want to change the C values, all you have to do is call the area pervious, and then you're more than welcome to change the C values. So a bit of review for that. If you're working on a catchment, the C values for the pervious areas, the defaults can be found on Defaults, catchments. And if you're working on the catchment and looking for the C value for the impervious area, you'll find that on Global Main tab. Now, along with this, you also have the capability of having 12D automatically calculate your C values using the method outlined in the AR&R 1987 design book. For this method, you do need your 1 hour, 10-year ARI intensity. Now, this is not directly read from your IFD table. You must manually enter this. And the reason for that is that from time to time, people somewhat adjust these values, and we wanted you to have that capability. So we're going to return now to the direct method. And for our example, we'll use these C values of 0.9 and 0.95. We'll increase that a little bit for our major events. The time of concentration can be directly inputted into 12D, or it can be calculated by the length, slope, and retardance. Separate TC values are available for the impervious and the pervious areas. To choose the method that's going to be used to determine the TC, we can go to our drop-down and see that we've got the direct method, friend equation, kinematic wave, Bransby-Williams, and Cutum velocity table. In future releases of 12D, we're expected to have additional TC methods as well. As we discussed with the coefficient of runoff, if you do not see a value for the TC method, then you would simply go to your Defaults tab, Catchments, and see what the default method is. In this case, it's specified as direct. If we return to the Catchment tab, you'll also notice that there are no direct values entered for the TCs. Once again, that means we're using the defaults. So back to see what those are in the Default tab, it's going to be 10 minutes for both the minor and the major events. Now, you can see that the concept for the pervious is exactly the same for the impervious areas. So back on these tabs, you can see that we're using the default values for those as well. So that covers the direct method. As soon as you were to switch over to one of the other methods, we'll say that we're going to use the friend equation. You'll notice that the length box, the slope box, and the retardance boxes now become active. Once again, they are blank right now, so if we were to run our storm analysis at this point, it would use the default values. Once again, the default values for the length, slope, and retardance would be 100, 2.5, and 0.15. Now, if you're going to the trouble to use the friend equation to calculate these values, you definitely are not going to be using the defaults. Most likely, you're going to come in and enter values for length, our slope as a percentage, say 1.5%, and then the retardance, which is similar to the n value, we'll say for a field it might be let's say 0.35, sorry, 0.15. You'll notice that it's much higher than the n value. Now, if you had these values, you would type them in, but more commonly you will draw a string inside 12D, and 12D will measure the length and the slope of that string and fill it into these boxes. That's the next step we're going to look at. If you're using a TC method other than the direct method, you're going to require at least the length and slope for the calculations to take place. 12D can calculate the length and slope for a catchment if you simply draw a string, a TC string, for that catchment. We're going to come up here and into a new model. We're going to create a model just for our TC strings. So I'm going to put it as DR as a prefix, standing for drainage, TC strings for my set number 1, and I'm going to draw them for my pervious area. Now, the reason I've been so detailed in my model name is so that I can keep track of the TC strings. I'm not concerned about the names of the strings or the color at this time. In order to draw a string, we're going to use the CAD's lines, not this first one, but we're going to drag it out to the one that has 3 or multiple vertexes on it, create line string. Now, I've already got my contour shown for my area, so what I'm planning on doing is starting at the top of my catchment, following down the path that the water would flow, and then I'm going to come across that down to the end, and I do not have to go back and go directly to the inlet. I could stop here, but the water is going to flow across that last little bit and then down into the inlet. At present, we're only allowed to have one roughness for this entire length. This is an enhancement we're looking at in the future to have multiple roughnesses. Now that the string is drawn, we have to do the linkage for that. Now, the linkages for catchments we've already been to before. That was found under Global Utility Models and was done via the file My Catchments. We're going to open this up by clicking on the folder and going down to Open. Now, the TC strings have to go either in this second column or the third column. Now, the TC string still belongs to catchment set number 1, so it will definitely be this row. And we've drawn it for the Pervious area, essentially the grass parkland that's up here to the north. So we'll click on that field, do a right mouse click. We're going to go looking for drainage TC set 1 Pervious. Now, if I select right, yes, I need to overwrite that original one. That file has been stored, so I can go finish. And if I want the calculations to be done, I have to hit the Set Catchments button. I get the message telling me the catchment details have been set successfully. And if I return to that catchments, and I take a look here, you can see that the length, the slope values have been calculated for that string. As one extra check for you, if I was to come back and do a window, tile horizontal, I could profile that string that we drew. Now, originally that string only had X, Y values and no Z. What 12D has done is it's gone and measured the length and the slope in order to do that calculation for you. The slope that it's calculated, if I was to come across and add on my tin combined, is referred to as an equal area slope. The area below that line is exactly equal to the area above. The downstream end has a matching elevation. If I was to toggle on the grades for that string, that 3% grade is the same 3% you saw entered, and of course if you added up the length of these segments, it would equal to the total length that you see over here.